Yeah, warm good afternoon to all. I'm Karthik, Assistant Professor, Mechanical Engineering Department from SNS College of Technology. Today we are going to have a small glimpse on iron carbide, iron carbide phase diagram. This particular phase diagram has many names. First is iron carbide phase diagram, Fe3C phase diagram, or iron cementite phase diagram, or iron carbon phase diagram. So next, so this is the complete phase diagram. So this phase diagram has y-axis as temperature, x-axis as carbon weight percentage, not as weight or not as percentage, it is carbon weight percentage. So the first one here, when we see into the x-axis, this x-axis is divided into two parts. First one is steel. So from 0.0001 to 2% of weight, 2% of carbon, that is 2 weight percentage of carbon, it is called as steel. That means the carbon up to 2% is mixed with iron. So at that time it is called as steel. From 2% to 6.5%, it is called as cast iron. So if we go beyond 6.5%, there won't be any mixing of, or there won't be any formation of solid solution, right? So if we add from 0 to 2%, it is steel. From 2 to 6.5%, it is known as cast iron, right? So now when we comes to y-axis, it is temperature. So we are taking temperature as in degrees Celsius. So the first one is around 210 degree, 723 degree, or it is 730 degree. This line is 910 degree Celsius, and this is around 1400. This is around 1492, and this is around 1539 or 540. So after that it is liquid, means that the steel will be completely dissolved or will be completely converted from solid to liquid at a temperature around 1540 degrees Celsius. In turn, it is called as melting point. So now I will segregate this iron carbon phase diagram into small pieces so that we will see one by one in a detailed manner. So for forming this iron carbon phase diagram, now before that we are going to see this ferrous carbon alloy classification. Primarily it is the metal is seen as divided into ferrous and non-ferrous. So ferrous is steel and can cast iron. Again, ferrous is classified into plain carbon, steel alloy, and high alloy steels. So here first thing what we are going to see in this iron carbon phase diagram is that we are going to see the major phases. Major phases means these are the phases which form in a single manner, means that they are single phases. They show a single phase, means in this area we are going to see only ferrite. This loop is austenite, and this loop is delta iron, and this loop is liquid, and this straight line is cementite. So here you can see on the last but not least, that is liquid. So you can see this major phases are formed in a single in a homogeneous or a single phase manner, right? So see, this is the delta iron, austenite, liquid, ferrite, cementite, or the single phases, or the major phases. So next, apart from this, when we come to when we come to the next thing, what we are going to see is here this loops are empty, means that here the loop is forming this loop contains the combination of the nearby major phases. So this phase has austenite and delta iron. Okay, as this phase it is near liquid plus austenite. So which, because this loop is near liquid phase and austenite phase. In this complete region you will have pearlite, which is a combination of ferrite plus cementite. So here you can see this loops are nothing but the combination of the major phases. So it is here austenite again, and we'll get ferrite, right? So now when we see to the carbon percentage, when we see the carbon percentage, we can for easy remembering, we'll convert this. So it is 0.10, 0.18, and 50, and 0.50, means 10, 18, and 50. So 10 is child age, 18 is teenage, and 50 is old age. So we'll keep it as in this manner. And again, if we take it as it is 0.025, it is 0.8, So we'll have 0.8, 2 and 4.3 and 6.67. So we'll keep it this manner. It means that 8 o'clock we are coming to the college, 2 o'clock is our lunch, 4:30 we are leaving the college, 6:30 we are going to reach the home. So that way this is uh, easy way to remember the carbon percentage. So the mixing of these major phases and the combination of the major phases and the inside loop and this carbon percentage are the major important thing of the iron carbon phase diagram. Okay, in next class we will see the invariant reactions that occurs at the iron carbon phase diagram. Thank you.